Hello, hello. Can we be talking today a little bit about social influence? Yeah, and how networks shape beliefs, how beliefs spread through networks. There's sort of two ways of thinking about this. One is from the individual sort of psychological perspective. We're talking less about that, and the other is from sort of the network perspective. Um, so it is it's the one kind of maybe one version of how these differ. The two terms that can be used. One is diffusion. So this is network perspective, right? How do things diffuse through a network? This is almost physical. It doesn't really have a people don't necessarily need to be involved at all, right? Like something you drop can diffuse through water, and then contagion is the other where there's sort of right. This is more relational. That something moves between two people. There's belief contagion or other kinds of contagion. So the kind of the big idea, which is will not come as a surprise to you, is that what we do, what we believe, is influenced by what others do and what those around us believe. This is, for those of you that have taken a sociology course, this is kind of one of the key concepts and ideas, and certainly it's central to a lot of communication as well. So one version of why this happens, one reason is because of something called network effects, not to be confused with the kind of networks we're talking about, certainly closely related. But the idea of network effects is that as something becomes more popular, it becomes more useful. So the example that people often give or used to give was a fax machine, which probably none of you have ever seen. A telephone is another example. An app, even we could use today, that a social media app. Instagram is not very useful if no one else is using it. But as more and more people use it, it becomes more and more useful. Part of the value of something is either the proportion or the total number of people that use it. So there are lots of things that fall into this category. So things like technological standards, right, are valuable. It's just good to have a standard, even if it's not the best one. It's good to get on the same page. Languages, right, or technologies often have network effects. That as more people use them, they become more valuable. A related idea is that of social constructs, which those of you who are comm majors will probably have heard of. Well, most people, I think, these days. But the idea of social constructs is concepts or things that have meaning and importance through social interaction, I guess is the word I forgot to put in there. That something like money, for example, a piece of paper, or bank accounts, the same, but especially if you think of physical money, it's really no more valuable or very. $100 bill is no more valuable than a $1 bill as far as the value of the paper. What can be done with it as a thing, right? You could write a list on it and be bad at that. You can make a paper airplane out of it. There's not much you can do with a dollar bill or $100 bill. The value is what other people will give you in exchange for it, right? That this is it's not an inherent value, it's a social value. That it's something about what other people believe it's worth that actually gives it its worth. And some of this is some of it is kind of, I don't know, shower thoughts, sort of kind of philosophical musings, but it really isn't though, right? At a very real sense, that the real value of something like money is that other people believe that it's worth something, and government and the institutions and the organizations behind it, like the Federal Reserve, etc. Part of what the Federal Reserve is, part of, for example, the federal FDIC, the deposit insurance, is giving people confidence that money will continue to have its value. The Federal Reserve targeting interest rates. It's institutions that try to give people confidence that money will continue to have the right value, that it will be worth the right amount. And this is why inflation is so possible, right? So easy, because you can if once people start to believe that money is not worth as much, they change their spending, etc. I won't go into like an economic history lesson. I've gone too far already, but hopefully you get the idea of what a social construct is and how that works. Another version of these, thing that can be influenced, whether social construct or not, are our beliefs about the world. Knowledge, right? That we gain these often from other people. What we believe, politics, etc., often is very closely tied to what those around us believe. That a lot of times, and some of this, there's like evolutionary or even just good rational reasons to believe the things that those around you believe. You know, if everyone, there's a kind of famous experiment where they had people like looking up at a building, like a group of either, like kind of change the size of the group of people who are looking up into the sky, the psychologist did at this experiment. And so if there's just one person looking up, then people walking by will usually just walk by. But once you get to 5 or 10 or 20 people all looking up in the air, then the people who walk by, they're just going to stop and look up in the air, because like the information we get, other people's beliefs give us information about the world. It is reasonable to gain information from what other people are doing and thinking and believing. So that's kind of the positive version of it. There are obviously negative versions of this. The conspiracy theories and things like this work in the same sort of way, right? That instead of beliefs coming from external places, they are kind of fed through a social belief system, and so there's real danger to this as well. Okay, so I want to talk. So that's like the broader idea of what is contagion, what is diffusion in networks. It's things moving from one node to another, one individual to another, and so there's some different like frameworks for how this might work. And I'm going to talk about the two kind of main big ideas. One is simple contagion, the other is complex contagion. For simple contagion, and maybe it's important, like some things spread via one or via another, and some are sort of in between, and neither of them is really a perfect explanation or perfect description of how things spread. Okay, so simple contagion, diseases are usually pretty well described by simple contagion. So in simple contagion, there's one person can spread something to one other person. Just like you only need to be with one person who had COVID to get COVID yourself. And so something like a small world network, the fact that we're all connected makes something like COVID really hard to stop. We talked about this a little bit in class, that is one reason that, even though we knew about it when it was just in China, it was very hard to keep it there. This, again, maybe we can think about small world networks in this, like SARS, for example, was stopped. There have been other diseases which were stopped before they had breakouts like this. And it just shows the importance. If we think about a small network, right, it's really clustered, but there are a few ties between clusters. And so if at the very beginning you can narrowly, or you can constrain a disease just to the cluster it started in, you can stop something from spreading. But once it is spread to a few clusters, there's going to be so many ties everywhere else that it'll be very hard. If we think about the interventions that we've taken over the last year and a half, to try to stop COVID, especially at the beginning, or that we might use to try to stop other diseases, most interventions really can be seen as network interventions if we think about them in network terms. So for example, stopping travel tries to cut off, if we think of that small world, right, clusters, we could think of people as being geographically clustered, and those long ties, those rewiring ties, are traveling between different clusters, right? And so the more we stop traveling, the more we stop those clusters. So, but the important thing, just like with COVID, the reason it didn't work is because once something is moved from one cluster to another cluster, cutting off that tie, it just is, there's not really a point, right? So once a disease has come from this cluster to this cluster, once it's here, it can travel freely within here. If you cut that tie that brought it there, it doesn't really help you. Things, on the other hand, like social distancing, masks, the shelter in place we did at first, all attempt at the kind of once it's within a cluster, within the US, for example, to reduce the degree, to slow down how quickly things spread from one to another. Okay, when it comes to simple contagion, the most important people to influence are those with high between-us centrality, at least, especially at first, right? That's what we talked about, the long ties. So as an example, if we look at this network, this is the karate network. If we imagine that these two people start off as infected, by the next kind of day or week or whatever our time step is, everyone who is a friend with them. So this is how these models usually are done. So this person would infect this one and this one and this one. Oops, sorry, not that one. This one and this one and this one, etc. And this person would infect this one and this one and this one, and all of their, whatever your degree is, you'd infect all those people, and then one step further than that, they'd infect all those people. So if we wanted to stop the spread, you can see, in this case, with both of these two infected, it's going to spread to all of these people pretty quickly. The key individual is this one right here, right? So that one that's standing between the disease and all of these people. So if this person could avoid being infected, for example, by, being vaccinated or avoiding whatever it is, wherever it is that these two people are, or, that everyone is, right? If only that node disappeared, then everyone else would be safe. So that's the idea of simple contagion. Again, diseases are pretty well modeled by simple contagion. The other common version of kind of framing how we'd see this is complex contagion. If we think of communication-related diffusions, belief-related diffusions, or contagions, I think it makes much more sense to think of them as complex. That usually just one person, no matter what it is, well, not almost without exception, you don't change your beliefs or behavior because just one person, who's different from everyone else told you to. If you had one friend who got an iPhone, or one person who, all of a sudden started totally changed the political party, then you probably wouldn't, that wouldn't influence you enough that you would change. Obviously there may be exceptions, but this requires that one way that they conceptualize this is that you need to have at least X people who, or at least N people who have the same belief in your friendship network, and then you will change, right? Once there are 10 of your friends that have an iPhone, it's like, okay, that looks pretty cool, I'll get an iPhone too. The other option is sometimes people do this as like a proportion. Once half of your friends have an iPhone, then you get one. But the key idea is that between groups, like if there's just one person, for example, one person flying from China to Seattle was enough for COVID to start in Seattle. One person one person who has a friend, with one set of beliefs, is not enough to change their beliefs, right? So complex contagions mean that we can have groups that persist in different beliefs, right? Because there's not enough there aren't enough mutual ties between the groups so that any individual in this group can be persuaded by their friends in the other group. So as an example for the if we thought about complex contagion in the karate network, we can think of it a couple of ways. If, depending on what the threshold is, if you needed to have at least 3 friends before you were, infected with this belief, no one else would be infected, right? Because there are only 2 people in the whole network that have this. Let's say you only need 2 friends. We could identify people that are friends with both of these. So it looks like this node here is friends with both of them, and that might actually be it. It's hard to tell where this edge goes right here. Like, does it go to this node or does it go all the way through? If it goes all the way through, then maybe this node is friends with both of them. And so this doesn't mean that things will necessarily stop there. So like, let's say just this one gets infected. Once this node's infected, then it looks like this one is now friends with this one and this one, right? So this would be affected in the 3rd time step. And so would this one. This one's also friends with both of them. But kind of really importantly, once this one is infected, So in the simple contagion case, once this one with between centrality, with high between centrality, the one that's this bridge, once they're infected, everyone in their group gets infected. They were the ones saving them. When it comes to complex contagion, if there's a bridge like this, even once they're infected, this group is safe, right? Because they only have this one friend. None of them have more than one friend that's part of this infected group. So maybe this whole group in here gets infected, but this group would stay safe because they only have, at max, one friend that's part of the infected group. Hopefully that makes sense. So that's kind of the key idea of complex contagion, is that that it's much more localized and resistant to sort of these kind of long cross group spreading. The one other thing I want to talk about, which is it's really, there's a connection, but it's kind of. I'll start with a story that and hopefully help you see the connection by the end of it. This is that paper by Duncan Watts, or it's a chapter of his book, Everything is Obvious, about special people. And I want to give a little bit of background. So he gives this example of the Mona Lisa earlier in the book. I think it might be in the first chapter. And he asks, why is the Mona Lisa the most famous painting in the world? And talks about how, artists and, curators have given lots of really compelling, convincing arguments for this. It's the technique that Da Vinci used, and it was the first case of using this, and it's the smile, and it's there's 100 different reasons that we can give. His argument, and I think the book is really convincing on this point, is that there had to be some painting that was the most famous. There may be 1,000 paintings that are just as good, just as innovative, just as important theoretically as the Mona Lisa, but whatever painting happened to sort of become a little bit more popular, there's sort of this, like we talked about, a success begets success, a rich gets richer dynamic that happens. Because once it's a little more famous, people like me that don't really care that much about art or painting, you still learn about something in school, right? And so you're going to learn about the most famous painting first, whichever painting that is. And that's, what are you going to teach your kids? The most famous painting. People who know nothing, they all know this. They all know about the Mona Lisa. People who know nothing about painting, like me. And so there's sort of this perpetual amplification of whatever is the most popular. Continues to becomes ever more popular. So something that's the argument, kind of in a nutshell, is that no matter what it is, something had to kind of capture this cultural space of the thing that's taught and known, right? The thing that we all know about, and it could have been just as easily one of 1,000 other paintings, but it happened to be the Mona Lisa. So how does this apply to networks? How does this relate? One version of this, and this is the argument that Duncan Watts makes, and I think that there's reason to push back on this, and I'm looking forward to our conversation. But that is that we, just like we couldn't predict which painting would become the most famous, can we predict who will trigger large-scale information cascades? Who is an influencer, in other words? Are people really influencers? And he argues that we can't predict very well. He talks about this paper that they wrote, where they looked, people, how many followers you have and how many retweets you had in the past, how much of your content was popular in the past, and use that to predict what's going to be popular in the future, who's going to be popular in the future. And it's just really noisy. You would think that whoever was really effective at creating, viral content in the past would do so in the future, but it's just not the case. It's just not the case. It doesn't work very well. And I think, this is the part where I think it's okay to push back a bit. That obviously some people are more likely, if Barack Obama tweets or Kim Kardashian tweets about something, it's much more likely to go viral than if I do. Right? That it does not mean that there are not people who are more influential. One way to think about it is thinking about the tweet itself, right? as a piece of content that if in hindsight, if we look at the thing that, goes really viral and everybody sees it, it seems genius and appropriate and well-timed, and the person who wrote it was perfect for it and they were connected to all the right people. But there were likely hundreds or thousands of similar tweets with similar attributes, right? The same, just as witty and just as funny and just as, the person was just as well connected. But there's just a big element of luck. And that luck plus the kind of the ever-changing structure of attention and who's paying and who's who and who's connected to who at any given time matters a lot more than the attributes of the information itself, or even things about the information spreaders. So that's his argument. I think I buy it less than the Mona Lisa argument. I'm looking forward to talking about it with you. And I think that the other part of it maybe that connects the two is that this is maybe closer to my version of what I think is right, is that I think that people in important network positions, people with social capital, with high betweenness centrality or excuse me, or eigenvector centrality, that they are more able to influence the world, that they are able to use that, and that we would expect them to have greater influence, whether we measure by retweets or anything else. But that network position that they got is also closely related to luck, and to that it's not anything about them as people. I won't quite go that far. To them as individuals, that it's not that network position and social capital are not just the result of hard work, but that they are often that they come from these network effects, right? That once you have a little bit of social capital, it's easier to get more and more and more and more. And the people who get attention get more attention and more attention and more attention. And other people who are just as smart and funny and wonderful just happen to, by bad luck, not get sort of on that train of amplification. So that's the main argument. Looking forward to chat more. Thanks, and talk to you soon.